this video, we are going to attempt enthalpy change structured questions. First of all, let's start with question number 1. A student investigates the combustion of methane in oxygen under standard condition. The reaction is represented below. That is, when methane gas, this is methane, when it reacts with O2, it is going to form carbon dioxide and water. And the enthalpy change here is minus 890 kilojoules per mole. Explain the meaning of enthalpy change, which is equal to minus 890 kilojoules per mole. So how we are going to write it? We are going to write it that what happens, as it is negative, so it is going to be first exothermic. What we mean by exothermic reaction, in which energy is released. Okay, in exothermic energy is released, but in endothermic, in exothermic what happens, energy is released, and in endothermic what happens, energy is absorbed. Energy is absorbed. So you are going to see here energy has been released, and you are going to see that how we are going to write it, that 890 kilojoules of energy is released when 1 mole of methane is combusted. Then they are saying that it is going to have, you are going to see that calculate the total energy released when 3 mole of CH4 combust. So if you want to calculate it, you know that when 1 mole of CH4 has been combusted, the energy related is going to be 890. So when 3 moles have been combusted, then enthalpy change is going to be minus 890 times 3, and it comes out to be minus 2670 kilojoules. Then they are saying methane combustion is exothermic. Explain them in terms of bond enthalpies. Reference the bond broken in the reactant and the bond formed in the products. So first of all, you must know that on left hand side what happens, bonds break. Okay, and on right hand side what happens, bonds form. So if we are talking about bond breaking, then there is CH4, this is hydrogen, and then we have oxygen, which is O double bond O. So you are going to see that bond is breaking, which is carbon hydrogen bond has been broken, and oxygen bond has been broken up. So here on the right hand side you are going to see that there is carbon oxygen bond which has been formed, and with water it is going to be oxygen hydrogen bond which has been formed. So if the reaction is exothermic, you are going to write that more energy is released when forming carbon oxygen and oxygen hydrogen bond as compared to energy absorbed in breaking carbon hydrogen and oxygen bond. So in this question, we are going to see when hydrogen gas reacts with chlorine gas to form hydrogen chloride, according to the equation, the temperature of the surrounding increase. Remember, in exothermic reaction, you are going to see that energy is released to the surrounding. Energy is released from the system, from system to surrounding. So what they are saying that the surrounding temperature increase, that means this reaction is going to be exothermic. And if this reaction is going to be exothermic, then what happens? Energy is released. Why it's exothermic? Because energy is released from the system to the surrounding, causing the surrounding to become warm. In the next question, they are saying, in terms of bond breaking and bond forming, explain why energy is released in this reaction. As this reaction is exothermic, so what we are going to write, that on the right hand side, as you can see, it's hydrogen chlorine bond, and these bonds are formed. These bonds are formed because bonds are formed on right hand side, and the bond between hydrogen and hydrogen and chlorine, they are getting broken up. So what happens? You are going to write in this question that more energy is released when new hydrogen chlorine bond form, then is required to break hydrogen and chlorine bond. State whether the products have greater or smaller chemical potential energy than reactants. So in this one, you are going to see, as it is going to be exothermic reaction, so what we are going to write, that compared to reactants, the product, because for exothermic reaction, like this is exothermic, and we know in exothermic these are reactants, these are products. So for exothermic, you are going to see that reactants, uh, they have reactants have reactants have high chemical potential energy as compared to products, as compared to products. So in the next question, they have given us a reaction, and they are saying, state whether the reaction is exothermic or endothermic. So in this, you are going to see, as the energy of product is greater than energy of reactant, okay, energy of reactant, so you are going to say that this reaction is going to be endothermic. This reaction is endothermic, and the explanation that you are going to write, that the products have have high potential energy, so the reactants absorb energy. So the ab- reactants, or you can say the reaction. So the reaction absorbs energy. So predict whether the temperature of the surrounding increases or decreases or stays the same. Explain your prediction in terms of energy transfer from the between the system and the surrounding. So here, as you know, it is going to be endothermic reaction. So what happen? Energy is absorbed from the surrounding. Energy is absorbed absorbed from the surrounding. So what happens? We are going to write that temperature will drop down, or temperature decreases. So in this question they are saying the decomposition of hydrogen peroxide is represented below, and we have to calculate the overall enthalpy for the reaction. Okay, so we have to calculate the enthalpy of reaction, and we are given two reactions here. So you are going to see first of all that in the reaction you can see one thing, that here we have 1 by 2 mole of oxygen, but here we have 1 mole of oxygen. So first of all, what we need to do, we are going to multiply it with 2. Why we need to multiply it with 2? Because the reason is that because we have 1 by 2 mole of O2 and it is 1 mole of O2. That is why we have to multiply this with 2. Okay, so if you multiply it with 2, then it would become 2H2O2 in liquid form, and that would be forming 2H2O liquid plus O2. In this way you have to multiply with the enthalpy as well. So this one would become how much? It would become minus 98.2 multiplied by 2. It would become minus 98.2 times 2. It would become minus 196.4 kilojoules. Now you are going to see for second equation, it is H2O in liquid state, but here we have 2H2O liquid and the final would be having 2H2O in gas form. So we want 2H2O in gas on right hand side. For that purpose we also need to multiply a second equation with 2, so that it would become 2H2O in liquid form, and over there it would become 2H2O in gas form. So you are going to see one thing, the product would be cancelled with the reactant, and the final equation becomes 2H2O O2 in liquid form, and that would become 2H2O gas plus O2 in gas form. It's in gas, so we have to multiply this with 2 as well. So this one would become, after multiplying by 2, this one would become, and one thing here which is very important, that what we want here, yeah, it's fine, yeah, we just need to multiply it with 2. So this one would become plus 88 kilojoules and the total enthalpy would come out to be minus 108.4 kilojoules, because we want this to be formed. That is why we have to multiply according to that. So in the next question, they are saying use the provided enthalpy values to draw a labeled enthalpy diagram for the decomposition of H2O2 in liquid form. So what happens first, if you are going to see that H2O2 is changing into H2O in liquid form plus 1 by 2 mole of O2, and this one is going to be exothermic. How we know it is exothermic? Because it is minus. Then for the next step, this H2 in liquid form has been changing into gas, and this process is basically what that process is, endothermic, because you are going to see it is going to be plus 44.0 kilojoules. So if we want to draw its diagram, energy profile diagram, we know we have enthalpy here or energy here, and there is progress of reaction on y-axis, progress of reaction. So you are going to see one thing here. This is what? This is H2O in H2O2 in liquid form, and when we are going to have exothermic reaction, so we know reactants are at high energy state and products are at low energy state. Okay, and here we have what? Again we have this H2O2 in liquid form, H2O in liquid form plus 1 by 2 mole of O2. Then what happens after that? We are going to have endothermic reaction, and the products formed are going to be like this, H2O in gas form plus 1 by 2 O2. So this is the way to draw this diagram. State whether this reaction is exothermic or endothermic. So you are going to see that final value that comes out to be minus 108.4. Then we are going to say that it is going to be exothermic. Then we have a next question, and they want us to calculate the overall enthalpy for the reaction, and that is what we are going to do. For the overall enthalpy of reaction, we are going to use the formula enthalpy of reaction is equal to energy absorbed during bond breaking. Bond breaking occurs on left hand side minus energy release during bond formation. So what happens there? If you are going to see on the left hand side, there is nitrogen, triple bond nitrogen, and we have 3 hydrogen bond, and on the right hand side we have 2 nitrogen hydrogen molecule, we have 2. So what happens? What you are going to do? First you are going to add for nitrogen bond, that is 945 on the left hand side because bonds are breaking, and then you are going to multiply 3 with 436, that is hydrogen bond, minus we have 2 moles of ammonia, and there are 3 nitrogen bond in 1 ammonia. So if they have 3 nitrogen bond and we have to multiply it with 2, so it becomes 6 nitrogen bonds. So 6 nitrogen bond, that comes out to be 391. So final answer that comes out to be is minus 93 kilojoules. Explain whether the reaction is exothermic or endothermic, and what we are going to say that this reaction is going to be exothermic. Why this reaction is exothermic? Why? Because the energy release forming nitrogen hydrogen bond which are on the product side is greater than energy absorbed during breaking of nitrogen bond and hydrogen bond. Okay, for this question we are going to do the same process. They have given the enthalpy change of different bonds. So we have to do for energy absorbed during bond breaking, which are on the left hand side. So there are 4 carbon hydrogen bonds. So we are multiplying 4 with 4, 1, 2. There is 1 chlorine bond. So I'm going to do 327. And then minus, there are 3 carbon hydrogen bond. 1, 2, 3. So we are going to do 3, like I'm going to put it in this way. 3 carbon hydrogen bond, that is how much? 4, 1, 2. And we have 1 carbon chlorine bond, that is 3, 2, 7. Okay, and I'm going to add with hydrogen chlorine bond, that is 431. So 431, and the final answer that comes out to be, that is going to be minus 103 kilojoules per mole. So in this question, what we are going to do, this is a question which has been related to Hess law. Okay, so how we are going to attempt this question? So in this question, they want us to find the enthalpy of reaction. This is enthalpy of reaction, and they have given us all the values which are enthalpy of formation. So for formation, I'm going to write elements here: carbon plus hydrogen plus chlorine in this box. And what I'm going to do, I'm going to keep it like this one like this box, and then this one like this box. So as it is enthalpy of formation that has been given to us, so first we are going towards CH4. For CH4, it is going to be minus 75 because they are 1 mole. So it's minus 75. And for CH3Cl, what it is going to be, that is going to be 1 mole, and that is minus 81. For Cl2, you know it is going to be 0. For HCl, it is going to be how much? Minus 92. So you know, according to Hess law, the box from where all the lines have been initiating, all the arrows have been initiating, that is going to be the starting point. So here you can see in box 3, this is box 3, this is 1, and this is 2. So all lines have been initiating from box 3, so it's going to be the starting point. And where all the arrows have been heading towards, that is going to be the ending point. So ending point is going to be 2. Now from starting point, if we are going to start from the starting point and we are moving from this direction to this direction, that is the ending point. And when we are moving from this point to this point, so this is root 2. Okay, there are two roots, root 2, and that is going to be root 1. Okay, so first of all, root 1 is equal to root 2. So what does that becomes? That becomes like for that purpose, that becomes root 1 is minus 75 plus enthalpy of reaction and is equal to minus 81 minus 92, and by solving enthalpy of reaction that comes out to be minus 98 kilojoules per mole. So this is going to be our answer. So in this part, in question number C, they are saying suggest one reason why the value calculated in part A differ from the value calculated in part B. So that value was minus 103, which you have calculated with average bond enthalpies, and this value is minus 98, which you have calculated from enthalpy of formation. So why the values are different? So you are going to give one reason, that bond enthalpies, they are average values, values across different molecules. Okay, they are average values across different molecules, while formation enthalpies are compound specific. Formation enthalpies are compound specific, and you are going to see one thing here, that they are measured under standard condition. They are measured under standard condition. So the overall reaction is reversed in a later step of thermodynamic cycle. Explain how this affects the sign and magnitude of delta H. So this reaction has been reversed, you can see. So what happened? The sign of delta H to reverse. Explain how this step affect the total enthalpy for the overall reaction. So this is what happened, like HCl has been broken up to hydrogen gas and chlorine gas. How this step affects? So this is bond breaking, and this step requires 431 kilojoules per mole of energy, and this step add positivity to total delta H because it's bond breaking, so it would add positivity. So what we are going to write, that this is a bond breaking step required 431 kilojoules per mole of energy, and you know it is positive. So what happened? This step adds positively to the total delta H. So in the next question they are saying explain why the combustion of propane is an exothermic process. The same thing that you are going to write, that more energy is released during bond formation as compared to energy absorbed during bond breaking. So in this question they are saying we have to find the enthalpy of reaction for this one. The same process we are going to do that energy absorbed during bond breaking minus energy released during bond formation. So how many carbon hydrogen bonds are there? So they are 1 2 3 4 5 6 7 8. So there are 8 carbon hydrogen bonds plus 5 oxygen double bond oxygen. And what we are going to do, we are going to subtract with, there are 2 oxygen carbon bonds in 1 carbon dioxide, so this one would become 6 oxygen double bond carbon. And what we have more, we have, this is 2 oxygen hydrogen bond in 1 water molecule, so this one would become 8 oxygen hydrogen bond. And now what we are going to do, 8 times carbon hydrogen is how much? That is 412, plus we have how many but there is one more thing that we have not seen, that carbon carbon bonds are 2 carbon carbon bonds there, so I have to add that one as well. So that is going to be 2 carbon carbon bond as well, that we need to add them. So first of all this one would become like, I can remove this one as well. So how many carbon carbon is 348, so 2 times 348, and then 5 oxygen is going to be 498 minus 6 into oxygen carbon bond, that is how much? That is going to be 799. 6 times 799 plus 8 into water, that is how much? 463, and total that comes out to be is minus 2016 kilojoules. Calculate the enthalpy change of the reaction. We have done it. The combustion of propane does not occur spontaneously at room temperature. So explain why an external energy source is required to initiate the reaction. The reason is going to be that an external energy source is required to overcome the activation energy, by breaking carbon hydrogen and oxygen bonds.